Hi everyone, my name is Mohammad Uzair and I'm a second year PG student in VLab supervised by Amir and Federico. So today I will be presenting my research work on multimodal video modeling. So our main motivation comes from the fact that our world is inherently dynamic and multimodal, and we often operate in different levels of abstraction, for example, objects, relationships or language to deal with different tasks in the real world. So our main motivation is how we can capture these complexities of the real world in deep learning framework. And to realize these capabilities, we basically develop a model which we call Video Forum. Video Forum is an any-to-any foundation video model which comprises of these diverse multiple modalities such as optical flow, detection, surface normal, depth maps, and these feature maps, etc. And this model is basically capable of performing any-to-any generation. So you can start from any set of modality to predict any other modality in both space and time. To realize the development of Video Forum, we mainly consider two main formulation parts. One is the pre-training data set, and then second is architecture and its training objective. For the pre-training data set, we basically curate our own large-scale video data set, which consists of multiple modalities, and we do it with the help of pseudo-labeling. And we start from a base data set that contains action categories and RGB videos, and then we use off-the-shelf models as pseudo-labelers to obtain the other abstractions. And for the architecture, we use transformer encoder-decoder model such as T5, and we apply mask modeling to pre-train the model. Once the model is pre-trained, Video Forum can then simply act as a foundation model that can solve different video tasks. So you give an RGB video and it will give you different kinds of prediction based on your target modality. So you can predict feature maps, geometric modalities, even captions and human poses, etc. In addition to the standard video task, Video Forum also enables any-to-any generation because it supports diverse modalities. So you can start with any modality, for example, RGB, depth map or caption, and you can predict any of the other modality. So this gives rise to like a very nice visuals, which is basically n cross n matrix of videos, where n is number of supported modalities. And in addition to that, we can perform multimodal video editing as well because our model supports different types of inputs. So we can provide, for example, RGB video, get the detections and use the detection and plug it back to the model with changed labels. And this can give rise to like different editing. So for example, a person in the grass, now it is in the sea, now it's in the snow, just by probing the labels. And with this any-to-any video framework, we conduct mainly two different studies. One is video prediction using chaining and prediction in abstract spaces. So by chain video generation, we basically have two set of pathways to generate a video. One is called direct prediction. So we start from a caption and directly predict the video. And the other one is a chain prediction, and which is our methodology, where we state that instead of directly mapping the raw caption to the RGB pixels, we can decompose this mapping into multiple smaller prediction steps. For example, we start from a caption, then we start predicting the depth map or transcription, siglib, detection, and then we use all of this prediction back to the model as a conditioning and predict the final RGB. So this variant is called chaining, and in our experiments we show that chaining improves over the direct prediction. And lastly, prediction in abstract spaces basically means that if we have a word model or a video model that can observe in the form of RGB pixels, what is the best prediction space where it can generate the rollouts or the future shift trajectories. So we start from some observations in the RGB domain, but instead of just predicting it in the RGB space, the prediction, we can roll out the future in different modalities. And our ongoing experiments suggest that predicting in some abstract spaces such as bounding boxes is more feasible and more accurate in comparison to predicting the future in RGB raw sensors. So that's it, and thank you once again.